In this video, I'm going to show a little bit more about the use of expressions in Mathematica. And we've started with a Mathematica notebook, which we see here. And in this notebook, I can enter various expressions, as we've seen already, including mathematical expressions and expressions that make use of inbuilt or user-defined functions, such as sine. And as well as the notebook, there is also a palette or a number of palettes that I can obtain. The palettes can be listed by clicking on this palette's menu here, and I can even install extra palettes that I've obtained from other places. But the basic palettes I have, there's this Maths Assistant, which is very useful because it gives me access to a number of commands and functions. For example, if I can't remember what the names of my functions are, I can click on a new cell, as it's called, and ask for the function to be entered, and it gives me a place where I can type in the argument. Say we ask for the inverse hyperbolic sine of -1, and I hit enter, and it gives me that value. So, suppose I wish to do some calculations of some data that I've entered. Well, how can I enter in more than one value? Well, I can enter in more than one value by using a so-called list. And a list is defined in Mathematica with the use of the curly bracket. And one of the nice things about Mathematica is that it is quite unambiguous in that normal brackets, like so, are only used for controlling the order of evaluation. They control the precedence of evaluation. So, for example, if I were to, in the cell below, just use the cursor keys to go there, I can type 2 plus 3 times 6. That gives me 30, but if I were to omit the brackets and evaluate that expression again, of course, it gives me 20 because the times operator has taken precedence, and this is obviously quite familiar with other programming languages. So that's what a normal bracket or normal braces do. The curly braces here allow me to enter a list of values. So I'm going to enter some values here, which must be separated using commas. And you can see above that when I supply the argument to a function, this is always done with a square bracket. So this is nice and unambiguous. Now notice something here, that the way in which I've entered these cells, you can see that my first expression up here was given expression 1, the next expression was expression 2, and the next expression was expression 3, and then 4 I've overwritten, so it has now become 5 because I've edited this cell and then re-evaluated it. This cell here, when I press enter, you can see that x has been defined as a list of elements. There's the output there. And this has been evaluated as expression 6. So these expressions are being sent somewhere. And behind the scenes there is a Mathematica engine that is processing all these commands. In fact, it's turning all of these things that you're seeing. So far, what we've seen so far is only ASCII text being entered. But everything is converted into ASCII, sent to the engine, and then calculated and returned back to the notebook and then presented to us. Just to show that that's the case, let's look at this notebook over here, and I'll make a new notebook, which I get from the File menu, and I'll put it over here, and let's just remove that palette. And because I've defined x in this notebook, the Mathematica engine is aware of it, and so x is now available on the right notebook, and I press enter, and there it is. So if I were to redefine x on this side and make x equals 3 instead, then on the left-hand side, I can type x anywhere I like, and I get the answer 3. So the order of the cells doesn't matter. It's the order in which I execute the cells that matters, and I can execute any cell I like by clicking on the appropriate cell delineator and entering it. So if I then evaluate this one, then I go back up here and re-evaluate this cell on the right-hand side, I get 3. So this can be a little bit confusing to begin with, and it's something to bear in mind. So I have calculated a list of elements, and I've given it into a variable x. So let's reevaluate that just to be sure that it's actually calculated it. And if I ask for x underneath, I now have the values 1, 2, 3, 4, 5. Suppose I want to square all of these values. Well, let's try x to the power 2. What does it do? It calculates the square of each and every element in that list x. So Mathematica, similarly to some other languages, including MATLAB, is able to iterate, if it can, over the elements of a list. And this is true not only of simple arithmetic operations, but also things like functions. So sine of x gives me the sine of 1, the sine of 2, the sine of 3, the sine of 4, and sine of 5. And notice that everything is being done with complete accuracy. It's being done algebraically. So actually, internally, Mathematica is not keeping a floating point or integer representation of any numbers. Actually, it's storing characters, and it's doing an algebraic operations using inbuilt rules on those characters. So when you ask for the sine of x, internally, Mathematica is iterating over each element of x and returning the values 1, 2, 3, 4, 5, which are exact values, and it's then passing those, and there's an algebraic calculation that is being used to give rise to these answers: sine 1, sine 2, sine 3, sine 4, and sine 5. If I wish to get the numerical value of those, that's when the n function will process each of those expressions and will give me numerical answers. So is it possible to do a plot? I'm going to close this notebook and save it. Now notice I've got a fair amount of lines of code here. If I were to delete all these lines of code from the notebook, remember that the Mathematica engine is still running. It's still retaining anything I've entered so far. So if I ask for the value of x, it's still defined. If I wish to get around that, I can go to the evaluation menu, and I can quit the kernel, and the kernel is what is the name for this Mathematica engine, the evaluation engine. I can quit the kernel and delete it. So if I really want to quit the kernel, it's now gone. This code is still available, and if I now ask for x again, you can see x is no longer defined, so x is now just an algebraic quantity. It hasn't been given some other definition. So let's create some x values. Now let's see what other ways I can generate a range of x values. Well, rather than generating them manually, let's see if we can generate a list of them. Well, let's have a look. We can ask, using the help command, we can ask for the choice, the definition of the range function. See that range generates a list of numbers. So x equals range 10 gives me a set of numbers from 1 to 10. That's one way of doing it. I can change that definition. I can say, instead of, I can copy and paste into another cell. I can say x equals range 1, 10, and you can see that I can put a step in between, which is 0.1, and remember this syntax is different from MATLAB, so pay attention to that. And I can generate a list of numbers from 1 to 10 with steps of 0.1. And notice that if I ask for this range, and this is a floating point value, in other words, it's got a little point that appears there, then all the numbers that have been generated are also floating point. But I needn't do it this way. I could define it just as well by saying 1/10. And now, all those values are given exactly. So actually, if I wish to retain full accuracy of the calculation, I should define my list of numbers this way rather than the first way using 0.1. But for many practical situations, this won't make any difference. Let's plot some y values. Let's calculate some y values first. And I'm going to calculate the sine of the x values. And there they are. And because I've defined them as fractions here, because I've left 1/10 there, then all these values here are now completely accurate. If I don't want to see the results of these evaluations, I can just put a semicolon on the end, and it will suppress the output. And you can see it's suppressed. So I have two different cells. I've defined some x values, I've defined some y values. Can I plot them? Well, let's do query of plot. Actually, the function I need to use here is list plot. And list plot asks for pairs of numbers. That's what this second line of syntax is given me. So let's look at the first line, which just asks for some y values. So I could just say list plot, and I could ask to plot the y values. And there they are. So I have a sine curve as I would expect. But it automatically fills in the numbers from 1 to the number of y values that I have, which is about 100 or so, and it just plots those. What I really want to do is plot the x and the y values. And if I just ask to plot x and y, it doesn't work. If I put them in brackets, like so, then I get 2 lines because it's plotting first the x values and then it's plotting the y values on separate curves. Now, if I wish to plot them as pairs, I need to manipulate them. I need to transpose the x and the y values so that the rows are swapped with the columns, and I can do that with the transpose function. So I do like so, and now I have a sine curve. So I've gone from 1 to 10, and I've calculated the sine of those values, which is what I wanted originally. But I can do more than that. I can actually use the plot function. Let's look at the plot function. Plot. Now plot allows me to do something different. Plot allows me to plot the value of a function. So let's enter that in. I'll say plot of sine of x. And now I can ask for x to vary, as it says here. You can see that in these curly braces, I'm giving a list of options. So I'll put a square bracket around the whole plot function, and I ask to plot sine of x from 1 to 10. Oh, and I need to say that I'm plotting x as a variable. And notice that there is a helpful highlighting in some kind of teal or green colour on this operating system anyway of those two numbers being tied together, those two values being tied together. They're associated somehow. So I hit return. I now have a nice smooth curve. Now there are a huge number of options for plots which we shall see at a later time. But one thing I can immediately do is I can simply grab hold of this plot and I can expand it, which is rather nice. So if I wish to plot multiple functions, similarly to what was happening up here, if you remember that we were plotting x and y, I'll just repeat that. I'll plot it somewhere in the middle. I'll put it here, and I'll plot x and y, and you'll see that I generated 2 curves. What I can do is I can replace each of those single plots with sets of pairs of numbers. So I'm going to generate a new set of numbers up here. So I'll just put it on the same line as my previous calculation just for convenience. It doesn't actually matter where I put it. Once it's evaluated, you can see that it's highlighted in blue, this y2 value. It's highlighted in blue because I haven't yet defined it. But if I now hit enter, y2 has now been defined, and I can see the y2 values explicitly by pressing y2. And there they are. Okay, I can highlight that cell and I can delete it. So let's plot down here. I will plot the x, y versus x and y2 versus x. So I can do that by saying transpose. And I'll put a list, and that list is the x and the y values. And what I can do is I can do click, click, click on transpose, and it will gradually highlight larger and larger sections of that expression. I can copy, and then I can paste, which is a very convenient way to do things instead of typing. I can press y2, and now I'm plotting 2 sets of pairs of numbers. Remember that up here I was plotting xy pairs. So as x1 was given with y1, x2 with y2, and I was able to obtain those pairs because I took the individual arrays of numbers, grouped them together into a 2-dimensional array, and then took the transpose of all of that. And all I've done here is I've done that for one set of data, I've done that for the other second set of data, and I've grouped all of that into a single list. And listplot is looking for each of the values in that list and assuming that each one of those is a set of data that it can plot. So when I do that, I get a sine and a cosine curve. Similarly, plot can do exactly the same thing, except I don't have to generate the data in order to plot it. I can just say I ask for the sine of x, and rather than just having one value in that list, I can now give it 2 values. So here I plot cos of x, and I have 2 curves. You can see that Mathematica has helpfully coloured them differently so that I can view them more easily. So that's the basics of entering expressions into notebooks and the generation of data and the plotting of data.